in this lecture, we're going to see about the ratio test for convergence. Okay, so the ratio test. So if you are given a given series, summation u of n, how do you find its convergence or divergence? You can take the nth term, un is the nth term, you take the n plus 1th term, a ratio between the n plus 1th term and the nth term. Now, if this ratio is greater than or equal to 1, then the series is diverging series. So then the series okay, so let's call this the ratio. So if r, however, so this is the ratio. So if r, however, is less than 1, if r is less than 1, then the series is convergent. And obviously, this ratio has to be evaluated in the limit n going to infinity. Okay, n goes to infinity. Obviously, this is the condition. So let's take an example and see how we go about this. So we are given to test the convergence of the series, test the convergence of 1 plus x square by 2 plus x square by 4 plus x to the power 6 by 6, and the series goes on, okay, up to infinity, goes on like that for x greater than 0. Now obviously we have to write a nth term for the series. So the nth term we have to write. So this is our given series. So from this we can write the nth term. Okay, so from this we have to write the nth term. So how we write it is, we write the nth term as, so this is the nth term. It goes up to x to the power 2n. Okay, so let me write the nth term here. The nth term un, the nth term is nothing but x to the power 2n divided by 2 to the power n. Okay, so that is the nth term. Okay, so the summation is over n, and n is going from 0 to infinity. Okay, 0 to infinity. Okay, so now this is our nth term, this is our given series. How do we test the convergence? So we'll find out the ratio. So the ratio of n plus 1th term divided by nth term. So we have, what we have is x to the power of 2, and wherever n is there, you replace by n plus 1. Okay, so wherever n is there, you replace by n plus 1. And you're dividing it by the unth term. So instead of dividing, I can multiply by the reciprocal of the unth term. So that will give me 2n. So this on simplification gives me x square n plus 1. Now again, this is evaluated in the limit n going to infinity. So you should remember that. So now I can, again, this the term in the bracket, I'm going to divide by n in the numerator and the denominator. So when I do that, I'll get 1 on top. Here also I'll get 1. Here I'll get 1 by n. Now obviously, when n is going to infinity, you can see that this term 1 by n will become 0. So this term becomes 0. So the answer that you get is x square. Okay, so the ratio that you get is x square. So we are told x is greater than 0. So for values of x, so r, so I might write the result here itself. So r is convergent or converging when x is when x lies between 0 and 1. Okay, so when x lies between 0 and 1. So when x lies between 0 and 1. And so the given series, so not R, so the given series, so UN, so summation UN is converging when x is between 0 and 1 and is diverging when x is greater than 1. So this is how we use the ratio test. So this is called the ratio test.